Hello, this is Ron Heiniger, Cropping Systems Specialist at North Carolina State University. Today we're going to look at the results from our starter, fertilizer, and other products placement and use trial that we conducted at the Chrome Research Site at the Peanut Belt Research Station near Lewiston, Woodville in 2020. There was some exciting results from this, and I'm hoping that you'll get the excitement as we get into this trial. First of all, let's step back and look at some of the things we saw in the early summer that will lead us into some of the results that we got from the yield data. This is the no starter plot. This trial was designed to look at no starter, starter fertilizer, products, rates, and placement. So here's a no starter trial. The sign is in the middle of the 4-row plot. You can see I'm holding one of the plants. My ring finger is pointing to the crown of the plant where nodal roots are coming out. These plants look very good. This appears to be a very good plot and a success for 2020. Let's look at our first treatment though. Here's 624-6, starter fertilizer, NP and K applied at 3 gallons in furrow. Now the critical element here is really phosphorus. That's the energy that drives cell division and root growth. And you can see these plants are larger here. You can tell by where I put it on the board there. Plant on the right is the 624-6. You can see more leaf area, more root mass. Now these are not at different growth stages. Both are at V5. No starter, this treatment, both plants are V5. These plants all in this whole plot are all at V5. It's just difference in growth, cell division, producing more root and above ground biomass. Here's the next plot that we looked at this summer. Here's 1027-0 at 10 gallons to the acre and a 3x2x2. This is a banded treatment placed on both sides of the furrow or the row. And wow, what a difference this made, didn't it? We saw this in these videos this summer. Lots of early growth here. There's 27 pounds of P2O5 here. See how much leaf area we have? Wow, look at those roots. Lots of secondary roots coming out of the nodes. We've got root hairs, all kinds of root mass here with this treatment, certainly compared to the no starter treatment. And here's what these ears look like when we put them in a table as we got ready for harvest. You can see the check doesn't look bad. There's actually a long year, but it didn't pollinate, did it? Not enough roots to take up nutrients and water at a time when pollination hit, so we had stress and poor grain fill. 624-6, look how well it filled. Look at the 1027-0 at 10 or 20 gallons. The 20-gallon rate is in the back of this table here. Wow, those ears look very good and very different from our check. They're probably only disappointed is the 1027-0 where we only applied it on one side of the row. There's clearly something happened there. We evidently didn't get those roots to that fertilizer quick enough to influence root growth in that treatment. So let's look at yield. Here's what the yield results show, and this is why I say I'm excited about this study. Look, 40 bushels, 50 bushel differences between the check and these starter fertilizer products, from Black Label to the 1027-0 at 20 gallons. That's a big difference there. Money to be made in those treatments. Now, if I had any disappointment here, it would be in two things. First of all, the 1027-0 in just the single band. As we saw with the ears, we see with the yield data only about a 5 bushel increase. Again, something happened. We didn't get those roots to that fertilizer quick enough. And that's a problem with a single band placed 2 to 3 inches away from the furrow. There's a chance those roots won't grow into that band in time to utilize that fertilizer. The other disappointment here is in the 1027-0 and the 3x2x2. With all that root mass and all that plant, why didn't it yield even more than the 624-6? Well, we've seen this before. You can have too much fertilizer. You get more root mass, but you also get more biomass above the ground. You get so much leaf area that you transpire so much water on a sandy soil that has a limited supply of water that you run out at critical times. And that's what happened here. All that big ground, above ground biomass would transpire too much water. Now, if we'd been like David Hula on his soil or an organic soil, maybe that would have given us that extra yield. But it did not here in the coastal plain, and that's exactly what we need to know. It turns out that 6 to 7 pounds of P2O5 in a furrow or close to where that root is was adequate for this crop. Now, what else can we do? And that's what we looked here. We wanted to see, are there other things other than fertilizer that we can influence root growth and yield with? Well, we know that part of what we see in our soils, particularly in the coastal plain, is we see less and less of biology, less earthworms, less bacteria, less endomycorrhiza, which are essential for the interface between the root and the soil to draw nutrients into the root surface. This is because we tilled our soils, we got less carbon available as a food source for this biology. Therefore, we see this cycle where we lose carbon, we lose biology, the soils start to compact, we then get less air movement into the soil, less biology. It's just a vicious cycle. So can we do something such as inoculate some of these soils with biology and enhance the performance of these soils that provide nutrients to the plant? Well, here's the Actinbacter. It happens to be levitate is what's called. It's a 5-15-5 with two bacteria, Bacillus lynchiformis and an Actinbacter. On this board, you can see the plot. On this board, you notice that this is the middle plant. The one on the left is a nose starter. The one on the right is 624-6. The middle plant is the levitate. You can see that's about the same size as 624-6. It's got about the same root mass as 624-6. Now, there's only 5 to 6 pounds of P2O5 here. The other factor, though, that's different is these roots are darker. There's more soil adhering to these roots after we pull this out of the ground. And that's because there's some mucilage or slickness to this root. This root has a bacteria that's infesting it. There's more endomycorrhiza or mycorrhiza infesting this root here with this biology. Another product we looked at that's a biological product without fertilizer is an endomycorrhiza product called Heat Shield. And you can see this plot. Again, very similar to 624-6. The root mass is very similar to 624-6, but we have no extra P2O5. There's no fertilizer here whatsoever. So clearly this endomycorrhiza is forming a relationship that's allowing the P2O5 from the soil itself, the phosphorus from the soil, to go into the root and influence this early growth. Again, you can see how dark these roots are. That was a characteristic of all of these biological treatments that we saw. How does this work? Well, you can see from this diagram here that has endomycorrhiza, these things actually grow into the root. They provide a direct pathway through the epidermis into the root. Normally, a root has to expend energy to exchange the nutrients from the soil into the root. In this case, less energy is required, therefore more P2O5 is absorbed directly into the root itself. So here's what these ears look like. There's the Heat Shield, very nice looking ears. We had a Radiate. Now that's not a biology treatment, it's a plant growth regulator, but they didn't look too bad. There's the Black Label Zinc we mentioned or showed earlier. We look at yield. This is where it got exciting, because look at these yield results. We're getting the same yield from some of these biological programs, such as Heat Shield, Levitate, or even that Radiate, the plant growth regulator, whereby building more roots in different ways, in a similar way that we're getting yield by building it with P2O5 fertilizer. So you can see here's a lot of promise, I think, for looking at and stimulating the biology of our soils to help improve the uptake of nutrients from our ground here. We're going to certainly want to look at these products in more detail. Now, the Heat Shield's not available on the market today. Radiate and Levitate certainly are. But Heat Shield is coming. I think we'll see some Heat Shield offered in North Carolina as we gather more data on this product. Very, very interesting material here. So we look at the plot there at the Chrome site. We learned some very important things this year. I'm looking forward to doing some of this again next year as we build our knowledge and database, as we figure out how best to grow the corn in a way that enhances yield and improves our soils. If you have any questions, give me a call. I'll be happy to answer them, or find me at some of these winter meetings. We'll be looking at these results in more detail.